Hi, welcome back to McClutchy Maths. My name is Natalie McClutchy and today we are on our 10th video in our index laws series, and this one is a meaty one. It's rational numbers. Now you might be wondering, what's a rational number? Is that a number that's logical, that can think clearly? Well, no, in the concept of mathematics, rational means a fraction. So we're looking at powers that are fractions, like a power of a half, a power of a quarter, a power of 2/5, and so on. Now this is our most complex content in our series so far to date. I would highly recommend that you get your head around everything else in the series first before you embark on this. This is Year 10 work in Australia. Also in the UK, it's Key Stage 4 and upwards. So it is quite high mathematics. So if you are in the lower strands of mathematics, get your head around the other stuff. There's no reason why you can't have a go at this too. Okay, so what we're going to do first is come up with our rule for fractional powers. What does a fractional power mean? So let's do a little bit of background first. We're going to go back to the beginning. We've been talking about squared numbers right from our very first video. So you would recall a squared number means that it's a number multiplied by itself. And this is the example we're going to use for the next few slides. 3 to the power of 2, or 3 squared, means 3 times 3, not 3 times 2. And the answer to that, of course, is 9. Now, very early on in our series, we also looked at square roots in our very first video. And you would recall that a square root is the opposite of squaring a number. And we would show it with this little sign that looks like a little bit of a tick with a hat on top, and it looks like the square root of 9. So what we're doing when we have a square root of a number is we have to actually think in our heads, what number multiplied by itself gives us 9? So you might start with 1. Well, 1 times 1 makes 1, 2 times 2 makes 4, 3 times 3 makes 9. So that means the square root of 9 is 3. So another way we could write that is, we remember that 9 is equal to 3 times 3. We can put that under the square root sign, and then we recall that that answer, the square root of 9, is 3. That's the number that is multiplied by itself to get to 9. Now, another way we could write this is this. You'll notice I've split out. Let's have a quick look at the previous slide again. You'll notice here it's sitting under the square root sign together. We can actually split that apart as the square root of 3 times the square root of 3. And we've just worked out that the square root of 3 times 3 is 3, because our answer is the square root of 9 is 3. Another way we could say that is, if you notice here, this is root 3 by root 3, and it's being multiplied by itself. It's the square root of 3 being multiplied by itself, which is another way of writing that is we're squaring it, because anytime we multiply something by itself, we're squaring something. Now, you would also recall that we've said that squaring something is the opposite of its square root. So effectively, we could actually put a line through this square root sign here and a line through the 2. They're cancelling each other out. One is the opposite of the other, and so the answer is just the 3. So the square root gets crossed out, the squared gets crossed out. They cancel each other out. So we're going to learn a lot more about surd rules in our upcoming series, which we haven't created yet, but we'll get there. These little things here, square root of 3 is called a surd. So anything with the square root, we call it a surd. We're going to learn a lot more about that in future videos. But just for today, we just need to get our head around that when we do a square root and then we square it, we cancel it out. Now, we're interested in this video in fractional powers. We've talked about that, rational powers. An example of that might be writing 3 to the power of a half, which is one of our most common fractions. Now, I'm just going to take a little park that information about square roots for a moment. We're going to now just have a quick look at index law 1 and what that means for fractional powers. So what I'm going to do here is take 3 to the power of a half, and I'm going to multiply it by itself. You could say that I'm squaring 3 to the power of a half. I'm multiplying it by itself here. So using index law 1, if we've got the same base, which is 3, my rule is if I've got times in the middle, I'm going to add the powers. And we know that a half plus a half makes a whole, which would be 3 to the power of 1, or just the number 3. I think you might be able to see where I'm going with this. So let's bring it all together. We saw that the square root of 3 times the square root of 3 was equal to just 3. And now we've seen that the 3 to the power of a half times by 3 to the power of a half was the same as 3 to the power of a half plus a half, which also made 3. So you can see this little connection here, that this square root of 3 and this square root of 3 to the power of a half when I multiply them by each other, we end up with the same answer of 3 each time. So you could infer that this is equal to this, and in fact, that is what is happening here. Anytime we've got the power of a half, it's the same as performing a square root. Now, this rule also applies to other types of roots. In fact, square roots are not the only kind of roots you can have. We did talk in our first video about cube roots, which is a number multiplied by itself 3 times to get to an answer. So for example, 2 times 2 times 2 makes 8. So that's 2 multiplied by itself 3 times. 2 to the power of 3 makes 8. Now to do that in reverse, to undo the power of 3, we take 8 and we can have what's called a cubic root of 8. And 2 is the cubic root of 8. 2 is the number that's multiplied by itself 3 times to get 8. So we can have these square roots, we can have numbers sitting above them as well that tell us how many times the number inside that little square root sign has been multiplied by itself. Okay, so we can also prove this law. We've just proved it using index law 1. We're going to just prove this again using index law 3 this time. Now we know we've talked about that square root is undone, or the opposite of squaring a number. So let's use index law 3 now. What I'm going to do, we've just discovered that the square root of 3 looks like 3 to the power of a half. What happens when I square that using index laws? Now we know from index law 3, when we've got brackets, that everything inside the brackets gets raised to the power outside the brackets. So the 2 is going to be multiplied by the half. So we're going to multiply those powers. So what I get here is a half times 2. Another way of saying that is half of 2, because when we have that multiply symbol, that means of. So a half of 2 we know is 1. So 3 to the power of 1 is just written as 3. So once again, this, we talked about our law being that a power of a half means square root. Square root of 3 squared is cancelling it out, and we can see that here. It's doing the exact same thing when we apply index law 3. So we've just looked at how to create this law in a few different ways. So here's our law in a nutshell and what it's going to look like. We've got those fractional powers and they are going to mean roots. So here's my rule using a little bit of algebra. Any base, so this big number here, the A, is our base. We've been using that letter in all of our videos so far. When I raise that to a fractional power, I can also write that as the square root of the base, but it's not just always a square root. Whatever this number is that's the denominator of the fraction becomes the root over here. So if this was a 10, a to the power of 1/10, it'll be written as the 10th root of a. If this number down here was a 5, that would be the 5th root of a. So basically what we're essentially saying is that this number a is made up of a number that's been multiplied by itself 5 times to get that power of 5 to be able to create the 5th root. Okay, so that's our rule. You've got to memorize that. Something also to just be aware of as well. When we have square roots, so which is the opposite of squareds, we typically just write that as a square root of a. We don't necessarily have to put a number 2 up here. You wouldn't get in trouble for writing a 2 up the top. So if we have, for example, a power of a half, we could just simply write that as the square root without a number here. But you could also write a 2 there if that helps you to remember things. Down the track though, it's just a lot tidier, and it's mathematical convention to just write it as a square root. Okay, we're going to do some examples now with our rule. So our first one's a fairly simple example. Write the number 8 to the power of a third using the root sign. So first of all, let's write our rule down. So this is our rule that we've developed over the last few minutes. So our base is this number a, so that becomes the number 8. Our power is a third, so this little m is going to become a 3, which means when I create it as with a root sign, it'll be 8 under the square root sign or under the root sign, and the power here will be a 3. It's going to look like this, the cubic root of 8. So that's what we call it when it's a 3, it's a cubic root. Now, we also know that the cubic root of 8 is 2. So if you've got numbers like this and they can be simplified, it's usually a good idea to do that. Most of the time your teacher will be looking for you to do that as well. So it's a good idea to know those cubic numbers, and we talked about that in video 1, and we went through probably half a dozen examples of really good cubic roots to know off by heart. Like 3 times 3 times 3 makes 27, like 4 times 4 times 4 makes 64, 5 times 5 times 5 makes 125, 10 times 10 times 10 makes 1,000. They're important cubics to know about. Okay, worked example 2, we're now getting into some algebra. Writing y to the power of a 7th using a root sign. So once again, here's our rule. So this a is our base, and this y here is our base. So we're going to just simply replace that with a y under the root sign. And the 7 is where the m is here, so there's going to be a 7 here as well. So it becomes the 7th root of y. So get yourself familiar with the language that I'm using as well, calling it the 7th root, or it could be, if this was a 5 here, it would be at the 5th root. If it was a 3, it's the cubic root, and so on. Okay, this one here now, I'm moving away a little bit from just using the rule, but I'm now just doing some algebraic techniques using fractional powers. In this case, I've been asked to simplify x to the power of 3 multiplied by x to the power of 2/3. Now, what this means is I've got the same base here, 2 x's, and I've got a times in the middle. I'm going to be using index law 1, which means I have to add the powers. So I'm going to do a third plus 2/3. And you need to remember that your rule about adding fractions, they have to have the same denominator. In this case, the denominator is 3, so we're all sweet. 1/3 plus 2/3 makes 1, and I can simply write that as x to the power of 1, or just x. In this worked example 3, we've also got some fractional powers again. Our base is j in this time. This time we've also got a division symbol. So that means we're going to apply index law 2 this time with same base, but we're going to subtract our powers this time. So I've got j to the power of a half, take away a quarter. Now you need to remember that rule here, that when we're adding or subtracting fractions, we have to have common denominators. In this case, I've got one denominator that's a 2, the other one that's a 4. So what I need to do is change the half so that it's got a denominator that's the same as the other fraction, which would be a common denominator of 4. 1/2 is equal to 2/4. So the way I could find that out is multiply this one by 2, multiply that one by 2, and I get 2/4. So now I've got j to the power of 2/4, take away 1/4, which gives me j to the power of a quarter. And I should also write that in this form as well. If I'm not asked to, I could just simply leave it in fractional form because the question doesn't tell me otherwise. But also I could demonstrate it using a root if I was asked to, which means it's the 4th root of j. And worked example 4, I need to write in index form the 3rd root of 10. Okay, so once again, let's bring up our law. This time we're going backwards. Our last examples went forwards and wrote it in root form. Now we're going back to writing it in index form. So once again, let's have a look at what's under the root sign. It's the number 10, that's our base. So it's going to become our base over here, the number 10. And this little power here, 3, is our 3rd root, is going to become the fraction 1/3. So it'll be 10 to the power of 1/3. Now it's tempting to pull out the calculator, but 10 is not a cubic number. It's when I do that on the calculator, I'm going to get in a rational number. So just leave it in index form because that's index form. Don't be tempted to stick it on the calculator because your answer will be wrong, then it won't be index form. And our next example here is evaluating the 5th root of m to the power of 6. Now, in this particular case, we've got our index law 3 at play. So we're going to bring this bit here first together. What I want to do is I want to firstly translate this into fractional form. Okay? Once I've translated this bit that's in the brackets into index form, then it'll be easier for me to then apply index law 3. So let's do that first. So I'm going to take this now. M is my base, so m comes out here, and this 5th root here becomes the fraction 1/5. So now I've got m to the power of 1/5, and it's inside the brackets, and 6 is on the outside of the brackets. Now I can actually apply index law 3. I couldn't do that when it was in root form, but now I can. Index law 3 tells me that when I've got a power inside the brackets, I have to multiply by a power outside the brackets. So I've got to be multiplying a 5th by 6. Now you might be wondering, how do I multiply a fraction by a whole number? Well, sometimes if a fifth goes into the number, like for example, if the power outside the bracket was at 20, for example, well, 1/5 of 20 is equal to 4. That would be nice and easy. But in this case, a fifth does not go nicely into 6. So what we're going to end up with here is a fifth times 6. Now remember, any whole number is also a fraction over 1. So 1/5 times 6 over 1, we multiply the tops, multiply the bottoms. So what we're going to have here is 1 times 6 will be on the numerator and 5 times this invisible 1 on the denominator, which makes m to the power of 6 fifths. Now, if you can have a look up here, this is where we've finished up. This is where we've started. Now, once you start to get to know and familiarise yourself with this law of how that translates into a fraction, you'll notice here that this here always becomes the denominator. And when you've got a power on the outside, that becomes your numerator. So if you were given this as m to the power of 6 fifths and asked to put it back into root form, you would know that the denominator is your root and the numerator is the power on the outside. So sometimes you might get a question asking you to take it from here back to root form, and that's the shortcut to doing that. Just memorizing that this becomes the base of your fraction and that this one here becomes the power on the outside. Okay, we're going to do one more example today. We're going to simplify a to the power of a third multiplied by a to the power of negative 1/3. So now we've got a few different index laws coming into play together. So once again, we're going to apply index law 1 because we're at the same base of a, and we've got some fractions up the top that need to be added together. So I've got 1/3 plus negative a third, means a third take away a third gives me 0. So now I've got a to the power of 0. So now we need to apply our 0 index law, which means we're going to have simply the answer 1. So sometimes you can see that even with fractions, we can apply all different kinds of index laws together and get different results depending on where we're going with it. Well, did you find our video helpful today? I sure hope you did, and I thank you so much for sticking it out right to the end of our video series on index laws. If you found this helpful, why not like and subscribe to our channel, hit that notifications bell so you'll always know when the next video is available. You could share this video with someone, just find that little share button, and send it to a friend, family member, or even your teacher. You can follow us on social media. We're on Facebook and Instagram, and why not even tell us in the comments what you thought of the video. I love to hear your feedback. It really helps me to connect to you. And if you've got any questions at all, or you're a little bit stuck with an index law question, you want some help, mcclutchymaths@yahoo.com is the place to reach me. Well, thank you so much for watching this series on index laws. I'm Natalie McClutchy. Have a wonderful day.